My name is Ondrej and I came here all the way from the Czech Republic. It's not that far. I work there for a company called Seznam. We do pretty much everything online. We're like a local, smaller copy of Google. We do full text search, maps, emails, domains, news, and so on, so on. I work as a front-end developer there, and I also regularly give lectures on web development topics on the Czech Technical University in Prague. So that's my trade. And let's have a brief look at what I'll be talking about. Of course, the main topic is async await in JavaScript. But first, we'll have to have a look at the JavaScript history to gain some context. So that will hopefully answer the question why we need or want such feature in JavaScript. Then I will explain how the async await stuff really works, and that will hopefully answer the question what is async await. And finally, I will briefly talk about transpilation, the complex process of providing the functionality to older implementations. So that will hopefully answer the question, how can we deliver this feature even to your grandparents' PC, which uses Microsoft Windows XP with the Internet Explorer 7 or so. My main goal here was to start with a joke, but turns out that the async await tech is not really funny. Fortunately, I managed to find a hilarious joke online, which I'm presenting now without comments. But I will explain that just a little bit. Yeah, it's async and await. Yeah, it's not the best joke, but probably the only one that really works. So let's just jump into the history section, where we learn about JavaScript, how old the language is, and how it evolved with respect to asynchronous processing, because we will really need to understand that before we do async await. Now, JavaScript was created in 1995, and for the first like 13 or 10, 12 years, the language was not developed almost at all. If you wanted to do some operation that would be blocking, you had to use a non-blocking API. And the reason for that is because JavaScript was designed to run in the very same thread that the browser uses to render stuff. So if you were to really block the execution, you would block the rendering as well, effectively making the page unresponsive. So that was the decision. That was the reason for those calls that would take some time, some non-trivial amount of time, to make them non-blocking. Fortunately, when JavaScript was young, there were not many asynchronous calls. We had like set timeout, set interval, XHR, and that's it. That's everything that was doable in JavaScript until 2008. What happened in 2008? Or 2009, Node.js came out. So the whole community like brainstormed and ran to Node.js so they can create something new, because Node.js was completely new. There was no standard library, and everyone wanted to contribute. So they wanted to port their favorite API, to port their favorite library. But nobody really knew how to do that, because asynchronous JavaScript on the server, that was something pretty raw, pretty new. So the easiest way to handle this was just like mirror what we already have in JavaScript on the client side. We have this set timeout function that takes a callback, so okay, we can do that as well. And this is how most of the Node.js APIs were created, like the FS module, the net, HTTP, and this holds also for client-side APIs, geolocation, navigator.getUserMedia, and so on and so on. These are APIs that are strictly modeled after the old callback-based asynchronous flow. What happened is what we typically label as the callback hell, because when you compose a lot of asynchronous functions together, you will have to juggle their callbacks and also their airbags, which are callbacks reserved for error handling. And this might get messy real fast, and you probably know that very well, so I'm not going to dig into this deeply. So people writing a lot of JavaScript code said that they need something else to handle the asynchronicity because callbacks are no longer maintainable. In 2015, the ES6 version of the ECMAScript standard came out, and it introduced the concept of promises to cure this. And these promises are a way to formalize how callbacks are supposed to work. There is something new in ES 2015, and now the interesting fact about promises is that they are completely polyfillable, which means that they're not something new in the language itself. They're just the design pattern. They allow us to reason about callbacks in a way that's more comprehensible, more composable. They formalize how callbacks work, how their signatures are defined, and they allow us to separate the implementation of a function, separate it from the flow of the code of the returned values, and also propagation of possible exceptions or rejections. So there is this recommendation that when you turn your code from a synchronous version to promise-based version, instead of returning a value, you resolve a promise, and instead of throwing an exception, you reject the promise. These promises were pretty popular back then, so we see quite a lot of these new promise-based APIs, fetch, web crypto, service workers, and also in Node.js the object fs.promises, which is available from the January 2018. So this one is new, fetch is not that new. I suppose that everyone in this room is familiar with promises. Creating promises is a complex art, and we're not going to discuss that. We're going to discuss how to consume a promise, how to deal with the promise that was returned by some call. So in this example, is this readable or not? Yeah, I cannot do anything with that. So if it's not readable, sorry. I have a function called getData, and I have not implemented that function. It's a library call or something. It returns a promise. So in order to process the value, I have to use the then method, the signature method of a promise. And unfortunately, all my callbacks, the process data, render data functions are asynchronous as well, so they also return promises. Fortunately, the whole concept of promises is based on the idea that you will be chaining multiple calls which are returning promises together. So this works, and it's readable, and if you see the code, you probably easily understand what it does. The problem is that not everyone uses the functional style. Perhaps you opted to using the object-oriented programming, using the this keyword in JavaScript, or you want to pass additional arguments to your functions. And chaining promises in this fashion is not that readable. I even had to use these arrow functions to make the stuff more nice. But if I was not to use arrow functions, I would have to use the explicit bind call to maintain the context. This gets hairy. We are not looking at a callback hell, but long chains of promises are not that readable as well. So that's the reason why async and await came to ES 2017. And they are here as a third approach to non-blocking stuff. And we're not talking something revolutionary. It's mostly just an evolution, the next step. First we had callbacks, then we had promises, and then we build atop of these promises the stuff with async await. And turns out that these keywords are just a simple syntax sugar for promise consummation. So you still need to use and you still need to understand promises to do async await. But when you decide to use async await, the code will be more readable and it will resemble the synchronous flow. I have a list of browser and server implementations that support async await out of the box. We'll obviously also talk about transpilation for older versions. So we start with the keyword async. I have an example here with my function getData. Perhaps the implementation is pretty simple. It just fetches the data from network using the fetch function and caches the data. So I might ask for a data that was retrieved before, and then I will just return the cached version, which makes my function a conditionally asynchronous function, which sucks because the return value is now based on the implementation. So as a consumer of this function, I can either receive a promise or not. And the keyword async helps here because it guarantees that the function will always return a promise, even if the return call returns a regular value. So the row number 3 in my code will return a promise that's already fulfilled with the value of the cache indexed by type. So we have a guarantee that a function prefixed by async will always return a promise, which is nice, but it's still like half of the work. And the second half is the keyword await. And we put the await keyword before calling a function that returns a promise. And this syntactic element will interrupt the execution of the function until the promise, which is being returned right next to await, gets resolved. And we are not talking about pausing or blocking the execution. We're still having an asynchronous function. So my function doIt will happily finish before the data is fetched, but it will return a promise, and the promise will slowly get fulfilled as the fetch will fulfill itself. So some basic observations about this. First, the rule number 1, you can use the await keyword only inside a function that is async itself, which makes perfect sense because by using the await keyword, you state that this function will be asynchronous. So the async prefix makes this publicly available information. The await keyword will throw an exception, a regular exception that might be catched by a try-catch block, should the promise right to await be rejected. The expression after await might be synchronous, so there is no need to return a promise when you do await. And these two keywords, async and await, don't help with creating promises. So if you have to create a promise yourself, there is no help for you. You will have to use the magic which is defined when using the new promise constructor. So we're now inverting the guidance about resolving, returning, rejecting, and catching. So this function now looks pretty synchronous, even though it relies on an async API. The core inside a function, the getData call, is asynchronous. It returns a promise. But fortunately, I can prefix it with await. And also, I can wrap the whole call inside a try-catch block, so it still looks pretty synchronous. Also, the process data, which is async, works like this. Render data also, because this function doIt is async itself. So I'm free to return a promise, and whoever calls this my function doIt will receive a promise from me. Turns out that you're able to turn a callback-based function into a promise-based function, which can then be used with the await keyword. The process is called Promisification, and I don't think that's a real word in English vocabulary, but it's used widely. How does the Promisification look like? So this is a theoretical implementation of a Promisification function that returns a function that returns a new promise. And I'm not going to talk about this in much detail, but you can check the code yourself. In fact, this approach is quite a bit popular because it made it into Node.js version 8. There is a built-in module called requireutil.promisify. And the implementation of the Promisify function is basically this one on the previous slide. with some more bells and whistles like caching and so on, but the core remains the same. So you can take your regular old callback-based API such as fs.unlink, which is used to remove files from your hard drive, and wrap it so that it returns a promise. And then you can use the promise as you would using then, but of course you can use the promise using await. So if you are using callbacks, you are not that far from using async await, but you first need to convert your callback-based APIs into promise-based APIs. There are some caveats, some issues. You might run into them if you don't do this carefully. So the first caveat is performance related. Say we want to use the fetch API, and if you ever used fetch, you know that it works in two phases. First, you fetch data, and it gives you just the few bytes of the response, and then you have to fetch the response. So we have a chain of two promises here. The first one returned by fetch, and the second one returned by the JSON method. And we can either await the JSON and return the resulting data, that would be line number 4, or we can remove one promise from this chain by returning the promise returned by response.json. That's row number 3 in the second example. And the second example is faster because every single promise you use makes the execution a little bit slower. Why? Because the callbacks passed to then when using a promise are executed on the next iteration of the event loop. So every promise you use delays the execution of your code by like 1 or 2 or 4 milliseconds. So we just want to reduce the number of promises that are being chained. Caveat number 2, parallel execution. Say you want to fetch 3 data sources. You have 3 URLs, you have 3 calls that you have to make to get all the data that you want to render. You might be tempted to fetch the first one and fetch the second one and fetch the third one, and you have await, so you have all of your data together. And now this works, but it effectively makes all these 3 HTTP requests serial. You will be able to do the second one only after the first one is done. Often you want to combine them and make them in parallel, and async await isn't going to help you. The only way to make these calls in parallel is to combine them using promise.all. That's also the reason why you need to understand and use promises, even when you opt to async and await. The final part of my talk about transpiling this. So this is a theoretical transpilation. We have an async function with a try-catch block and an await keyword. And we're imagining how the code might be transpiled to older JavaScript implementations that do not understand these keywords. So probably we want to wrap the code that follows after await into a promise. So we can just wait with the execution unless the fetch returns. So the transpilation process shall be rather straightforward. We can easily take the async await code and wrap it into a regular set of promises. And you might think that you will just use Babel for that. You will download the appropriate plugin or use the configuration and so on and so on. Many people are happy doing that. They just download Babel, they apply the Babel to their code, they test that it works in IE, and they release the stuff and go home. Have you ever looked at the code produced by Babel? Yeah. That's sometimes a good idea because async await is promised in a really crappy is transpiled in a really crappy way. I would like to say that the async await transpilation in Babel just sucks because these async await calls are transpiled to generators, which are functions with asterisks. And because not every JavaScript implementation supports generators, the Babel has to transpile these generators as well. So they're further transpiled to a complex state machine for a regenerator, which is a really large implementation of the generators in JavaScript. And this is all unreasonably complicated and unreadable. So I cannot recommend using Babel itself for transpilation of async await. Instead, there is this little plugin. Unfortunately, I'm not its author. I found it online. It's called fast-async. This is a link, so you can easily find it online. It's a plugin for Babel that converts async await to promises directly without using generators or regenerator. You just have to supply the promise implementation, which can be polyfilled. By default, this plugin called fast-async uses its own promise polyfill implementation, which is called Zosan, and I have really no idea why. But you can specify your own polyfill, or perhaps you target browsers that are able to do promises natively. So in your Babel configuration file, which is called .babelrc, when you define your plugins, you add that fast-async plugin that's recommended to you by me, and you also configure the plugin itself by passing it this compiler dictionary with the no runtime option turned on. And that will remove the built-in Zosan promise polyfill, and you're free to either add your own polyfill or add no polyfill if you do not need that. And this makes the transpilation really painless and fast and readable. Yeah, and that's it. So if you have any questions, ask them now or never.